Here are solutions to homework set number 10 for ECE 476-676 Advanced Embedded Systems. This homework looks at GPS and Raspberry Pi Pico. Now the problem I'm going to look at is trying to measure how flat is Fargo using a GPS sensor. Here I'm going to try to find out how flat is Fargo. So here I've got my little Pi Pico set up with a GPS module. It's recording my latitude, longitude, and elevation. When I hit button 14, it beeps and starts recording data. That zeroes out the position, and as I drive, it'll tell me the distance that I've gone, latitude, longitude, and displays my elevation at the same time. I'll drive around Fargo and see how flat it is. So here we are on 45th Street, one of the main freeways through Fargo. We will record the elevation as I drive up and down 45th Street. Here I am driving along 45th Street, measuring the latitude, longitude, and height above sea level. Here we are, just arrived on campus. So that's the idea. Want to run around Fargo, measuring the elevation as I drive down 12th Avenue North, going east-west, and then 45th Street South, going north-south. See what the elevation is. Now, in terms of hardware, I'm first going to connect the GPS sensor to the Pi Pico using serial port 1. If I had a second one, I'd have attached on serial port 0 and 1. In terms of software, there's a couple different stages. The first part is I will create an instance of the serial port at 9600 baud. That's reading the GPS module. I will then, so here's the idea. I'm going to try to measure how the elevation of Fargo using a GPS module while driving around 12th Avenue North and 45th Street South. Recording the data as I drive and display it. In terms of hardware, connect the GPS module to the Raspberry Pi Pico using serial port 0. In terms of software, I'll first create a serial port on instance 0, connected to pins 0 and 1. I'll come up with a routine to read a single line of the GPS starting from a $, ending with the carriage return, and then check to see if that works. So that's what this routine does. It just reads the GPS module, verify that I can read it. So here's the data coming in. It says I've got valid data. At that point, I'm pretty certain that the GPS module is working. The blue light is blinking. So here's the Pi Pico. There's the GPS module. You can see the blue light blinking. It is picking up a signal. And that shows up on the serial port with the data coming in. Okay, now that that works, let us try to parse the data. So I'm going to use the split command and pull out, if the first command was the GPGGA message, pull out the first, second, fourth, and ninth field. There's the time, latitude, longitude, and height. Okay, that seems to work. Let's go another step. Let's write a subroutine that just pulls out that information, returns time, latitude, longitude, and height. And this is my latitude, longitude. I'm actually just doing this in minutes, stripping out the degrees. I'm not going to travel that far, so ignore the degrees. Part of the reason we're ignoring degrees also is I'm starting to get rounding errors, floating point overflows. Okay, I can pull out the latitude, longitude, and so on. Now comes the fun part. I'm going to pull out that data, convert to meters, display it. If I hit button 14, I will reset the home position, start recording to a file. Hit it again, I'll stop recording. So here's the data. When I hit button 14, that zeroes out X and Y, starts recording. Hit it again, that stops recording. Setting to a file. Okay, with all that, I can start collecting data. So now that I can collect data, here's what it looks like. The time from when I hit button 14, change in latitude, longitude, height, that's just height in meters. Start collecting data to a file. Now, one thing I want to look at is how noisy is the GPS sensor. So one approach is to just have this GPS sensor sitting on my desk, stationary, record for 10,000 seconds, however long that was, find the mean, standard deviation. So here's what the data looks like when stationary. Blue is X, green is Y, Z is red. The data has a mean, standard deviation. The standard deviation tells me the noise level. The sensor is not moving, it's just sitting on my desk, but this is what's being reported. That's the noise level, which tells me that based upon this reading, I can read height to about 14 meters. That's just the noise level of the sensor. That's if I am stationary. If I start moving, like driving around in the previous video, I get much better data. So driving due south along 45th Avenue, this is a fairly flat part of the road. Assuming the road is completely flat, about 2 miles of road. Here is the reported elevation. I assume the road's flat. Again, I don't really know if this is the noise from the sensor or noise on the road. The road looks flat. Assuming it's flat, the standard deviation then would be the road or the sensor. When I'm moving, the standard deviation drops quite a bit. It's now 0.73 meters for standard deviation, meaning I can measure height to about 1 meter with a 90% confidence interval. Okay, now that I have an idea of how accurate the sensor is, let's drive around. So here's the path I took. I went from campus, just on the other side of the freeway, driving west on 12th Avenue North, then south on 45th, down to 72nd Avenue North, west out to Horace, turned around, came back up, and stopped the recording. What is the height during that trek? Well, plotting it, here's what the height is in meters along that path. It's got a mean, standard deviation, so this is the average height along that track of about 5 or 6 miles. Here's the standard deviation. Again, the road was not that erratic. It was actually a pretty smooth road. This is sensor noise. Again, I don't really know sensor or road. That's what the data was. What the data says is that the total standard deviation is 2.74. If I attribute that all to the road, that means that Fargo is flat to about 4 meters. And this is going over a 7-mile stretch, telling me how flat Fargo is. And that is homework set number 10. I'm going to use the Raspberry Pi Pico along with a GPS sensor to record my latitude, longitude, and height, and from the height, give an idea of how flat Fargo is. Again, I don't exactly know how flat it is, but I know that it's within 4 meters. This is the sensor noise plus elevation noise is 4.5 meters, 90% confidence interval. The city itself has got to be less than that. Homework set number 10 for 476.